Well, let's get some answers from Kathy Keinert. She's an engineer here at NASA Marshall. Kathy, what are some of NASA's design challenges for the next generation of spacecraft?
Jennifer, we have a great bunch of talented folks from around the country helping us choose the best design. Some work for the government, some work for private companies, and others for universities. SLI is designing the whole system for the next generation of reusable launch vehicles.
Okay, we keep saying next generation. What was the first generation?
Good question. The Space Shuttle is the world's first reusable launch vehicle. The Space Shuttle Orbiter is designed to be launched again and again, so it is our first generation of reusable launch vehicles, or RLV. And that's why we talk about the next gen RLV.
So what are some of the things you're doing to get ready for the replacement of the Space Shuttle?
Well, the most important thing is safety. The challenge is to make the vehicle as light as possible without reducing safety or strength.
Yeah, that's understandable. So I guess being lightweight isn't the only thing that matters.
That's right. A part of the system might actually be heavier if, say, it made the whole system safer or less expensive to operate. The weight increase might reduce costs and help make the crew travel safer.
We definitely want to keep space travel routine and safe for those next generation space explorers.
There are many things for the SLI program to consider and test. Different types of engines, fuels, and vehicle shapes, and these are only some of the parts of the entire system. We call the whole system the architecture, and we mean everything from mission planning to launch on orbit support to landing and getting the vehicle ready to fly again.
Kathy, that sounds pretty challenging. Well, so have you come up with any designs yet?
First, we had to decide what we wanted to do in space before we started designing. NASA sees the next generation RLV as doing two main things: getting to the International Space Station and taking satellites into orbit. We select preliminary designs that best meet our needs. One challenge vehicle designers face is what type of engine to use. Some engines use kerosene and liquid oxygen. Others may use liquid hydrogen and liquid oxygen. Each option offers advantages.
Well, why so much interest in engines?
The type and performance of the main engines have a major influence on the whole spacecraft. They influence safety, weight, maintenance, preparation time, and cost.
So what are some of the other things we can look for in the next generation RLV?
Well, one of the things that you might see are the reusable boosters that fly back to the launch site.
A booster? What's that?
A booster is the primary or first stage of a multi-stage rocket.
Okay, that makes sense, but you said the boosters are going to fly back. How do they do that?
Well, they have onboard computers for navigation, and they also have onboard computers that work sort of like your nervous system, alerting astronauts and people on the ground whenever there's any kind of problem.
Right, that's really important. Now, besides the onboard computer systems, how else are you going to improve safety?
Well, when a spacecraft goes from space to our atmosphere, friction with the air can heat up the outside of the vehicle to temperatures over 1600 degrees centigrade. That's hot enough to melt steel. The part of the vehicle that protects the crew is called the Thermal Protection System, or TPS.
So what is the thermal protection system made of, and how does it work?
Currently, we are looking at a number of materials, but all thermal protection systems work in two basic ways. The first way is absorption. Like a pot holder, you design the skin of the spacecraft so that it can absorb the heat of re-entry without damaging the vehicle. The second way is radiation. The outside of the vehicle is designed to radiate the heat from re-entry like a fireman's coat protects him from a fire. Some designs will combine both of these approaches to protect the astronauts and spacecraft from the heat of re-entry. The TPS has to be thin and light, but still strong enough to do the job over and over again.
Kathy, that sounds difficult.
Well, it is challenging, but remember, crew safety, it's our number one concern. For the next generation spacecraft system, we'll have other changes too.
Well, what sort of changes?
Well, for instance, the Space Shuttle carries both cargo and astronauts. For the next generation RLV, we want to divide those jobs. We are looking at two vehicles, a cargo ship with no crew on board and a smaller crew transport vehicle. Protecting the crew is much easier when they are not part of a huge cargo vehicle. The crew transport vehicle has a rocket engine to help it get away from the launch vehicle in case of any problems. The cargo vehicle doesn't need all the equipment required to protect people, so it can carry more cargo. It's really a win-win situation.
That's super, Kathy. Thank you so much for all the information on the Space Launch Initiative.